In class 11th, we had learnt about the IUPAC nomenclature of organic compounds. Now let us learn about the IUPAC nomenclature of coordination compounds. Let us first take few examples and then learn the rules while naming them. Now observe this complex K4FeCN taken 6 times. In this complex, potassium is the cation and FeCN taken 6 times is the anion. Always the cation is named first. So the name begins with potassium. And you can see here the second rule, whenever a ligand repeats itself more than once, prefixes like bi, tri, tetra, penta, hexa, etc. are used. So here you can see there are two entities inside the coordination complex, iron and cyanide. Always the ligands are to be named first. And you can see here there are 6 cyanide ligands. So the name continues as hexa, indicating 6 cyanide ions are present, and the name of the ligand cyanido. The name has to end with O because cyanide is a negatively charged ligand. Whenever a negatively charged ligand is present in the complex, the name has to end with O. And finally, only the central metal ion is to be named, and it is iron. Iron has a Latin name, that is ferrum. So whenever a metal has its Latin name it by its Latin name. So it becomes potassium hexacyanide. And then here the complex has a negative charge. If the complex is an anion, then the name of this metal ion has to end with ate. So it is potassium hexacyanide, and always just next to the central metal ion, the oxidation state of the central metal ion has to be indicated in parenthesis. So finally the name is potassium hexacyanide 2. Then now let us see another example. The central metal ion is nickel. As per the rule what we have learned, always the ligands have to be named first, and you can see there are 4 cyanide ligands. So the name is tetracyanido nickel, and nickel doesn't have any other special name, any special Latin name. So you can directly write it as tetracyanido nickel. And because it is an anionic complex, the name of the central metal ion has to end with ate. So tetracyanido nickelate, indicate the oxidation state of nickel. You calculate and see what is the oxidation state of nickel, and it is equal to 2. So indicate it in Roman letters. Remember, the oxidation state of the central metal ion has to be indicated in Roman letters in parenthesis. Now let us see the next complex, ZnOH taken 4 times 2 minus. In this complex, there are 4 OH minus ligands, and zinc is the central metal ion. So the ligands have to be named first as per the rule. So first the ligands have to be named because there are 4 OH minus ligands. The name starts as tetra, indicating 4 ligands, hydroxido, the name of the ligand, followed by the central metal ion zinc, and because it is an anionic complex, the name of the central metal ion becomes zincate, and oxidation state of zinc is calculated and it is equal to 2. So finally the name of this complex is tetrahydroxido zincate 2 ion. Now see this next complex. In this complex, nickel is a central metal ion and carbonyl groups are the ligands, and 4 ligands are present. So the name of the complex is tetracarbonyl nickel. In the bracket indicate the oxidation state of nickel. That becomes the name of the complex. Now let us see another example. CONH3 taken 4 times, H2O taken twice, Cl3. In this complex, the complex is a cationic complex. So we will start naming the cation first. So and inside the coordination sphere we start naming the ligands. And in this complex, if you observe, there are 2 types of ligands, ammonia and water. Whenever 2 ligands are present, the ligands have to be arranged in alphabetical order first, and the one which comes first in the alphabetical order is to be named first. As per that ammonia and water, among these 2 ligands, which is to be named first? Whenever neutral ligands like ammonia and water are present, they are given some special names. So in case of NH3, NH3 is named as amine, AMMINE, amine, and water as aqua or aquo. Therefore, the name of the complex starts like this. It is tetramine diaqua cobalt in this complex. Because amine and aqua ligands are present, first we have to arrange them in alphabetical order, and while arranging in alphabetical order, the prefixes attached to the indicating the number of ligands present should not be considered. For example, while arranging amine and aqua in alphabetical order, don't consider tetra and di, because they only indicate the number of each ligand that is present in this complex. So neglecting the numerical prefixes, consider only the name of the ligands and arrange them in alphabetical order, and then start naming the complex. Because there are 4 NH3 ligands, you can name it as tetramine, then diaqua, then what is remaining inside the coordination complex? It is the central metal ion, it is cobalt. So cobalt, write cobalt, and then indicate the oxidation state of cobalt metal ion, and it is equal to 3. Then what is the counter ion present? Chloride. So write chloride, and once again remember, you need not indicate how many counter ions are present in the name of the complex. So it is tetramine diaqua cobalt 3 chloride. Now you observe this example, CrEn taken thrice, Cl3. In this complex, it is a cationic complex, so the complex has to be named first. So let us start naming the complex. In this complex, we have one central metal ion chromium, and then the ligand present is ethane 1,2-diamine. And ethane 1,2-diamine is a polydentate ligand. So whenever polydentate ligands are present, and you need not use the prefixes bi, tri, tetra, etc. Instead, we use the prefixes bis when 2 ligands are present, tris when 3 ligands are present, and when 4 ligands are present, then tetrakis. So as per that, now let us apply this rule and then try to name this complex. So the name of the complex is tris ethane 1,2-diamine chromium 3 chloride. Finally, the name of this complex is tris ethane 1,2-diamine chromium 3 complex. Now let us learn about the rules we have learned so far in naming this complex systematically. The ligands are always written before the central metal ion in the naming of the complex coordination complexes. That means whenever you are naming a coordination complex, always the central metal ion is named after the ligands are named. When coordination center is bound to more than one ligand, the names of the ligands are written in an alphabetical order which is not affected by the numerical prefixes that must be applied to the ligands. When there are many monodentate ligands present in the coordination compound, the prefixes that give insight into the number of the ligands are of the type di, tri, tetra, etc. When there are many polydentate ligands attached to the central metal ion, prefixes used are bis, tris, tetrakis, etc. The names of the anions present in a coordination compound must end with the letter O, which generally replaces the letter E. Therefore, the sulfate anion must be written as sulfato, chloride as chlorido, bromide as bromido, and so on like that. The following neutral ligands are assigned specific names in coordination compounds. For example, NH3 is named as amine, H2O as aqua, and so on. After the ligands are named, the name of the central metal ion is written. If the complex has anionic charge associated with it, the suffix ate is applied to the central metal ion. When writing the name of the central metal atom in an anionic complex, priority is given to the Latin name of the metal if it exists. An exception is mercury. The oxidation state of the central metal ion or atom must be specified with the help of Roman numerals that are enclosed in a set of parentheses. If the coordination compound is accompanied by a counter ion, the cationic entity must be written before the anionic entity. And after that, we already have seen how these complexes are named. For writing the name of complexes, there is a guided slide. Now using this, we will see how complexes are named. Now let us see how this complex is named. The name of the complex is Cr, H2O taken 5 times, Cl, Cl2. In this complex, first identify the cation and anion and the name of the simple ion. Here the complex cation is Cr H2O taken 5 times, Cl 2 plus, and the anion is Cl minus. Give each ligand a name and list them in alphabetical order. The ligands present are aqua and chlorido. Name the metal ion. So which is the metal ion present? Chromium. And what is the oxidation state of chromium? It is equal to 3. So chromium in parenthesis 3, indicating the oxidation state of the central metal ion. Next, name the complex. The next complex is K3FeCN taken 6 times. In this, potassium is the cation and the anionic, it is an anionic complex, and the anion present is FeCN6 3 minus, which is a complex anion, and the ligand present is cyanide, and it is the name of the ligand will be cyano, and because it is a natively charged ligand, it can be written as cyanido. So then name the metal ion. The metal ion present is iron, and its Latin name is ferrum. So it becomes ferrum, and it is a anionic complex. So the name has to end with 8. So the name of the metal ion becomes ferrate, and because it is in +3 oxidation state, indicate the oxidation state of the central metal ion in Roman letters as 3. Then name the complex ion name of the metal ion. Therefore, the name of the metal ion is hexacyanide 3. Then name the compound by writing the name of the cation before the anion and leaving only space between the ion names. Therefore, finally we have to name the counter ion present. So, the name of the complex is potassium hexacyanide 3 complex. I have given here many complexes, and you can have a practice in naming these complexes because classroom time does not permit to explain each name of each complex. So, you can have a practice in writing the name of these complexes. This is the homework for your tomorrow's class. Anyhow, I have given the answers for these questions so that you can verify and correct yourself. Thank you very much for listening to me carefully.